Hi there, thanks for watching. In this lesson I'm actually going to compare a couple of features between Magento and Shopware to get you going with Shopware 6 if you're already familiar with Magento 2. And specifically in this lesson I'm going to deal with dependency injection. So first of all, dependency injection is kind of like the one of the most vital elements of Magento 2. And in a similar way it's also making up for a good part of the architecture of Shopware itself. So out of the box, well, dependency injection is in there. It's working nicely. You can do things with it and etc. So there's not much more to tell about it itself. While dependency injection itself is maybe not that complex. However, the configuration of dependency injection is really what makes the clock tick. So for instance, in Magento, there's dependency injection configuration by using a file called di.xml, and that's leading into a long listing of opportunities. Well, in Shopware, we have the same kind of opportunities. So let's actually zoom into those configuration types and see what the dependency injection container of Shopware can do, and whether that kind of resembles the thing that you're also familiar with in Magento. So first of all, before diving into that matter of how actually a certain configuration is in Magento and similar to a specific feature in Shopware, we first need to get the basics straight. So as soon as we talk about dependency injection, we also need to talk about the classes that you could inject. So I'm coming up with a little bit of a dummy example to help you understand the code in a better way. And starting with an interface. So there's this interface with a namespace called swag_example. Swag example could be a namespace in Shopware. Well, swag actually stands for Shopware Agentur, Shopware agency, but it could similarly be also the namespace of a Magento module. So within that module, within that plugin, I'm creating an interface, and that interface simply has a getter and setter to put some kind of foobar value into this class, and then getting the value out again as well. Well, the interface is actually implemented in a class where all of that getter and setter stuff comes to being. There's the addition of an internal variable foobar, but it's kind of straightforward. Now, as soon as we've created a class and an interface like that, within Magento, often we start talking about backwards compatibility, that you could use the interface as a service contract, inject that interface into your own class, and then thanks to the fact that the interface is an abstraction of the real implementation, your other class is depending upon the abstraction instead of the real-time implementation, and that basically boils down to standards for backwards compatibility. Now, a similar case we can come up with a dummy class like this one. So it's a third piece of the puzzle, some usage of service. I don't really care about how it's being used, where it's being used. It's just that this is a class that is injecting itself with that interface that we've just created. And that interface is now suddenly being instantiated into an object. Well, if you know your PHP, you know that this is actually impossible. So as soon as you would try to instantiate an interface into an object, you would get a fatal error, cannot instantiate interface. Instead, the interface needs to be mapped into a class, and that class could be instantiated into an object. And apparently that kind of translation mechanism, that if we request the some service interface, we actually get a some service class. That translation is basically the responsibility of the dependency injection container handling this dependency injection. Within Magento, that dependency injection container is called the object manager. Within Shopware, that's actually based upon the Symfony service container, and we're going to see more about that service container now in a bit. Because actually this little example already proves that we need to have some kind of configuration. We need to map that some service interface into the class before actually this is starting to work. Well, with Magento, that's what we call a preference. A preference could be added to a di.xml file in your own module, and a preference is then mapping the interface into a class, and then thanks to this little translation we can inject the interface, and then automatically the object manager is taking care of this. So the big question would be, does Shopware include a specific tool like this as well? And obviously it does. So the Shopware specification actually boils down to a specific file, source resources config services.xml. But theoretically that services.xml could be a different file name. It could also be a different language, not XML, but YAML or maybe even PHP. But that's a little bit beyond the point. There's a certain file, and normally that file should be called services.xml. And that services.xml holds your own service definitions. Now, equal to the preference that we just saw, we can declare a service with the name of the interface and then use that new service as an alias for some service. Or actually, it's almost my feeling that it's the other way around, that actually some service is, or some service interface is pointing to the actual some service. So it's the alias to that service called some service. So hopefully making not that much sense. But anyway, this code basically resembles the preference that we just talked about in Magento. Now, in real life, in Shopware, a lot of times when you're referring to an interface or you're referring to a class, then the ID is often actually not identified as a fully qualified domain name, so a fully namespace like this one. But the ID is actually more like a shortcut, a little word indicating that there's a service definition behind that string, behind that word. But we're going to see more about that as soon as we dive deeper into those service definitions. But step one within this question about the dependency injection, dependency injection is simple, but the configuration always leads into more trouble or more knowledge. And then the question could be, do we have an alternative for a Magento preference within Shopware? And the answer is basically yes. And let's refer to this as a service alias. Now there's more DI configuration types in Magento. So often I start with explaining a preference and then I move on to the other part, which is a factory. So instead of actually injecting the instance that I require, so for instance the some service class directly into that other dependency, some usage of service, I'm also able to inject a factory into it. And there's multiple reasons why this could be beneficial. For instance, every time when I inject a specific dependency into a constructor, the dependency is always a singleton. It's always the same instance, even if it's used throughout dozens or hundreds of other constructors. And if I don't want to have that singleton behavior, if I don't want to have a reusable instance, but I want to have a fresh instance, then actually a factory allows me to do so. So I'm injecting the factory, and then once the factory is there internally in my own class, I can call upon the create method, and then outward comes a fresh new instance, a new some service class or object. Now, it's interesting to note that actually in Magento, a factory could be there on the file system, or it could not be. And if it's missing, if it's not actually there in a PHP file, it will be automatically generated by the object manager or by Magento in general. So in Magento, we have a factory, and then the next question would be, what kind of pattern do we have in Shopware which is matching up with this same principle? Well, and the answer is basically a factory. So in Shopware, we also have a factory. It boils down to the same file that we've just seen with that service alias. There's this service definition, and now within the tag, the XML tag of that service definition, I can simply just add a factory. This doesn't mean that in my own code I would inject the factory. No, instead you're actually injecting the service that you want. In this case, an example util. However, once that example util has been injected, or the request of it is being handled by the service container, then automatically the service container knows, oh, but this specific class I need to put together, I need to put that class or that object together. I instantiate that object by using this specific factory class with a method create. So it basically boils down to the same thing, but it's slightly different. So within Magento, the factory is always injected. Within Shopware, you're never injecting the factory, or, well, you could, but then it's on purpose. But normally, if you simply want to have a class being created by a factory, you simply just wrap that factory within the service definition, and then the Symfony service container is basically taking care of the rest. Another important fact to note is within Magento, a factory is automatically generated or not. But within Shopware, that factory is never automatically generated. You always need to come up with that factory class yourself. Now, moving down that list, there's another pattern within Magento that is kind of like known, which is a proxy. Proxy is basically similar to a factory. You could inject this proxy within some kind of PHP constructor simply by just taking the original class, in this case some service, and then appending \proxy to it. However, a lot of times actually people say that using a proxy is mostly needed not to allow for the code to work in a certain way, but it's much more needed for performance tuning. And that means that actually it's less of a good idea to inject the proxy in the PHP code. And instead, this little snippet of XML is zooming into a specific class, some usage of service, injecting it with this other dependency, the some service class, but then allowing for that proxy to be used as a configuration on top of the normal PHP behavior. So there's nothing wrong with the PHP behavior, but the proxy in this case is just making sure that the performance is guaranteed by adding that proxy, by adding lazy loading on top of it. Well, that's also important to note. Why do we have a proxy? To allow for lazy loading, to make sure that the dependency, in this case some service, is injected into that other class, but actually it's not injected yet. It's only being put together with all of its own dependencies once actually one of its methods is being callable. It's a lazy loading of a specific class. Well, and basically that phrasing of a proxy being a lazy loading mechanism actually comes up in Shopware right away as well. So back to the same service definition, services.xml. Every time when I have a specific service and I see that performance bottleneck is basically there, I could just simply add this lazy is true keyword, and then I'm actually done for it. And just like in Magento, that the proxy is automatically generated, that's also the case in Shopware. And it's actually not really related to Shopware at all. It's just Symfony, the dependency injection framework of Symfony itself already allows for little tricks like this. So far so good. We've actually come already quite some bit. We've covered already preferences, the factories, the proxies in this case, but to me there's always 6 in total. So next up would be types and virtual types. Now, actually this little snippet of code is something we've seen just now earlier already with the proxy, because as soon as we want to put this proxy to use within Magento, I actually need to zoom in to the PHP constructor of a specific class. That class in this case is again some usage of service. And then actually by using this XML arguments array, I can zoom into a specific PHP constructor argument called some service, and then basically replace that regular PHP argument with something else. And in this case, actually the original some service object is now replaced with a some service proxy object. Well, types are kind of like a little bit similar to virtual types. In Shopware, actually, a mechanism like virtual types doesn't really exist, but it's also not really needed, and that's, well, a little bit diving into the dependency injection container a little bit too deep. But we can still see that in Shopware we have this way of treating arguments in a certain way. And that's basically what we can do again with that same services.xml file. In Symfony, our terminology, this would be a service argument. Because actually within that surface definition that we talked about earlier, for instance, in this case, a little command, I can inject an argument of type is surface, referring to a real live object. In this case with ID is kernel. And then under the hood, the kernel ID is a string referring to yet a class name, and that class name is then being instantiated and injected into this other class called example command. But the bottom line is basically that by using surface arguments, you can just refer to a specific PHP argument and remove it or change it into something else. So just like Magento has types and virtual types, in Shopware we still have those surface arguments as well. And coming back to the listing of 6 different dependency injection types, preferences types, virtual types, proxies, factories, well, there's only one left, and that's the plugin mechanism. Well, actually, plugins are similar to the Shopware mechanism as well, but it goes a little bit too far to actually explain this in full, so I'm just keeping it short. As soon as we start to compare the feature of Magento plugin interceptors to something in Shopware, it's kind of like a surface decorator that matches in most of the cases. Not entirely, it's a different mechanism, but you can do that same thing. So it's basically the same mechanism as we've seen in Magento. The goal is that there's this PHP class, it has public methods, and for each one of those public methods, you can intercept its behavior. You can do something before that method is being executed, after that method is being executed, or around. So doing something with both the input arguments and the return value. And that's basically also where a surface decorator comes from. It allows you to take the original object with all of its different methods and wrap actually a decorator around it, so that for each method you can do something before, after, or basically around. So hopefully it's trying to shape up a bigger picture. That we've just gone through all of the different dependency injection configurations of Magento, and that we've seen that actually there's similar behavior or almost identical behavior in Shopware depending upon which configuration we're talking about. But I would say that actually if we're talking about dependency injection and we compare the functionality and also the flexibility of Magento to Shopware, I would say that actually the same functionality, same flexibility is there in Shopware, and not necessarily because of Shopware itself, but basically because of the fact that Shopware is based upon the Symfony framework, and thanks to the Symfony service container and its all dependency injection architecture, we can match basically all of that mechanisms of Magento within Shopware itself as well. I'm just flying through all of these topics, but hopefully it's just shaping the overall picture that a lot is possible. And still in upcoming lessons, I'm going to dive deeper into dependency injection. I'm going to dive deeper into, for instance, that stuff upon factories, but also the surface decorators, just to explain everything inside out. But while comparing the bits, hopefully you get pretty much enthusiastic about Shopware as I did earlier as well. So keep on watching, and I hope to see you in a bit.